In this video, we're going to plot the supply and demand curves and then find the equilibrium price and quantity when we're given the equations for supply and demand. So from this question, we know that the supply is given by QS is equal to 1 over 5P minus 6, and the demand is given by QD is equal to 50 minus half P. The first step in plotting the supply and demand curves is to isolate P to the left side for both the quantity supplied and the quantity demand equations. Now, the reason why we like to do that is because we want to put the equations in the form of y equals mx plus b. Notice that this coordinate grid that I've got drawn here has P on the y-axis and Q on the x-axis. This is standard to economics. We always tend to put price on the y-axis and quantity on the x-axis. So writing these supply and demand equations in the form of y equals mx plus b, where P is the y-axis variable and Q is the x-axis variable, makes the question or the solution much cleaner and easier to plot. So rewriting the supply equation, we know that 1 over 5P is equal to QS plus 6. And then multiplying both sides by 5, we end up getting the inverse supply curve, which is P is equal to 5QS plus 30. Now, notice how I said the inverse supply curve. Now, the reason why this is the inverse supply curve is because we've got P isolated on the left side and Q as part of the equation on the right side. So the above equation here, where I've got QS on the left side, is the supply curve, where I've got P isolated on the left side, that is the inverse supply curve. And that's going to be the same thing for demand. Now, if we isolate P for the demand equation, we end up getting that half P is equal to 50 minus QD. And therefore, when we multiply both sides by 2, we end up getting the inverse demand equation, which is P is equal to 100 minus 2QD. Now we have to plot the supply and demand curves now that we've got the inverse supply and demand curves. So I always like to start with the demand curve since it is downward sloping. This is actually going to make it a bit easier to draw since we can get 2 points on the axis of the plot. So if we sub in QD is equal to 0, we can see that P will be equal to 100. So for the first point in drawing the demand curve, we end up knowing when QD is equal to 0, we get a price of 100. Then similarly, when P is equal to 0, we can solve for QD, which will be equal to 50. So this gives us 2 points for our demand curve, and since we know it's a linear equation, we can draw a straight line to connect these points. All right, let me make that a bit better. There we go. And that is the demand curve. Now, moving over to the supply curve, we know that the y-intercept is 30. So when quantity supplied is equal to 0, we know that price will be equal to 30. Now, in order to get the second point when plotting the supply curve, I actually like to look at the y-intercept of the demand curve and then sub that into the supply curve, and then that will give me a point in which I can connect my line. So if we get or sub in a price of 100 into the supply curve, we can solve for the quantity supplied, which will actually be 14. And then we can draw a line that connects the 2 points, and that is going to be the supply curve. So with that, we've actually plotted the supply curve and the demand curve for this market. And next, we need to solve for the equilibrium price and quantity. Now, equilibrium in an economic market like this is where supply will intersect demand. So we know that the equilibrium price will be right here, and we know that the equilibrium quantity will be right here. Now, the first step in solving for the equilibrium quantity and price is to set the quantity demand equal to the quantity supply, which is an equilibrium condition for this market. And I'll denote this with Q star. So if we plug Q star into the supply equation, we end up getting that P is equal to 5Q star plus 30. And plugging Q star into the demand equation, we end up getting that P is equal to 100 minus 2Q star. So notice that we've got two equations and two unknowns. This implies that we can actually use substitution to solve for the equilibrium quantity and then the resulting equilibrium price. Now, a side benefit from actually isolating P in both the supply and the demand equations is that it actually makes substitution quite simple, since we know that 5Q star plus 30 is equal to P and 100 minus 2Q star is equal to P. We can just set those equations equal to each other like this to get an equation in which we can simplify to solve for Q star. So if we isolate Q star to the left side by adding 2Q star to both sides, we end up getting that 7Q star is equal to 70. Now dividing both sides by 7, we end up getting that Q star is equal to 10. And then this is going to be the equilibrium quantity. So subbing the equilibrium quantity into either the supply curve or the demand curve will yield the equilibrium price. So let's sub this into the demand curve. I like doing this just because the demand curve looks a little bit easier to work with. So we know that P star is equal to 100 minus 2Q star. So P star is equal to 100 minus 2 times 10. And then P star is equal to 100 minus 20, which is 80. So therefore, we know that the equilibrium price will be 80. And that wraps up the solution for this problem. If you haven't noticed already, I've got the steps listed on the right-hand side. So the steps to solving for the equilibrium price and quantity and plotting the supply curves when given the equations for supply and demand are to first isolate the price for both the supply and demand curve. Then we want to plot the supply and demand curves in the grid below. Then when we're subbing or solving for the equilibrium price and quantity, we first want to set the quantity demand equal to the quantity supply and denote that with Q star. Then we can use substitution to solve for both P star and Q star. Thanks for tuning in. If you found this video helpful, please like and subscribe, and I'll see you later.